In this video, we are going to see the actual PV diagrams of IC engines. The aim of the experiment is to study the actual PV diagrams of 4-stroke and 2-stroke engines of SA and CA engines. So first one is your actual cycle for 4-stroke cycle in SA engine. So left side we are having actual cycle, on the right side we are having a theoretical cycle. The comparison of actual cycle and theoretical cycle for 4-stroke cycle in SA engine was shown. The line 5-1, it represents the suction stroke in which charge enters into the cylinder. The suction of mixture is possible only if the pressure inside the cylinder is below the atmospheric pressure. So the suction line lies below the atmospheric pressure line, which is indicated here. The burnt gases are pushed out only when the pressure inside the cylinder is above the atmospheric pressure. So this process is represented by line 1 to 5. The above two processes, that is 5 to 1 and 1 to 5, gives the area in the form of small loop, which is called a pumping losses. The compression stroke is shown by line 1 to 2, which shows that inlet valve closes, that means IVC, a little beyond the point 1. At the end of this stroke, there is an increase in pressure inside the engine cylinder. Shortly before the end of compression stroke, the charge is ignited with the help of a spark plug. So thus both the pressure and temperature of the cylinder will increase, but the volume remains constant as shown by the line 2 to 3. Expansion stroke is shown by line 3 to 4. The exhaust valve opens, which means EVO, so that is little before point 4. Then the burnt gases are exhausted to the atmosphere. Also, the actual pressure in such an engine is only about half the theoretical valve. The corners are rounded off because both inlet and exhaust valves do not open and they suddenly close. So next one is actual cycle for 4-stroke cycle in CA engines. The comparison of actual cycle and theoretical cycle for 4-stroke cycle in CA engine was shown. The line 5-1 represents suction stroke in which the air enters into the cylinder. The suction of air is possible only if the pressure inside the cylinder is below the atmospheric pressure. So the suction line 5 to 1 lies below the atmospheric pressure line. The burnt gases are pushed out only when the pressure inside the cylinder is above atmospheric pressure. So this process is represented by the line 1 to 5. The air is adiabatically compressed in cylinder during process 1 to 2, which takes place after inlet valve close, so that is IVC. Shortly before the end of compression stroke, the fuel valve opens and fuel is injected into the cylinder. The fuel is ignited due to temperature of highly compressed air inside the cylinder. The combustion takes place at a constant pressure as shown by the line 2 to 3. Actually, the combustion at constant pressure is not possible as fuel will not burn completely as it is introduced into the cylinder. Then the charge is adiabatically expanded in the cylinder as shown by the line 3 to 4. At the end of expansion stroke and little before BDC, which is bottom dead center, the exhaust valve is opened, which is EVO. Theoretically, both compression and expansion are adiabatically followed, but in actual cycle it is not possible because of heat and pressure losses. Actual area on PV diagram per cycle is less than theoretical because of lower pressure rise and pumping losses. So next one is the actual cycle for 2-stroke cycle in SA engine. The comparison of actual cycle and theoretical cycle for 2-stroke cycle in SA engine was shown. The suction stroke is carried out from transfer port open and transfer port close, which is TPO and TPC. During half of the suction stroke, the exhaust port is opened. Now the volume of air fuel mixture is entered into the cylinder. It happens as the piston moves from TDC to BDC. During second half of the suction stroke, that is BDC to TPC, the air fuel mixture is compressed and burnt gases are pushed out. A little beyond top transfer port close, the exhaust port closes, which is EPC, at point 1. These processes are represented in theoretical cycle as 156 and 651. Now, the air fuel mixture is isentropically compressed in the cylinder. So, this process is shown by line 1 to 2. Before the end of compression, the charge is ignited, which is denoted by IGN, with the help of a spark plug. The combustion of air fuel mixture increases the pressure and temperature of the products of combustion. During this process, the volume remains constant. So this is represented by the line 2 to 3. The expansion process is shown by line 3 to 4. At the end of expansion stroke, the exhaust port opens, EPO, at 4, and burnt gases are pushed out in this atmosphere. During this, the pressure falls suddenly to the atmospheric pressure. As the piston moves towards bottom dead center, the volume of burnt gases increases from 4 to 5. At point 5, the transfer port opens, which is TPO, and the suction stroke starts. So last one is actual cycle for two-stroke cycle in CA engines. The comparison of actual cycle and theoretical cycle for a two-stroke cycle in CA engine was shown. The suction stroke was carried out from transfer port open to the transfer port close, TPO, TPC. During half of the suction stroke, the exhaust port is also opened. The volume of air is entered into the cylinder. It happens as the piston moves from TPO to BDC. During the second half of the stroke, that is BDC to TPC, the air is compressed and burnt gases are pushed out. So beyond transfer port close, the exhaust port closes, which is EPC, at point 1. Now the air is compressed isentropically in the cylinder. So this process is shown by line 1 to 2. Before the end of compression, the fuel is admitted into the cylinder by means of fuel injection, which is denoted by INJ. The combustion of fuel increases the pressure and temperature of the products of combustion. During this process, the pressure remains constant. So this is represented by line 2 to 3. The expansion process is shown by line 3 to 4. At the end of the expansion stroke, the exhaust port opens, EPO, at 4, and burnt gases are pushed out into the atmosphere. During this, the pressure falls suddenly to the atmospheric pressure. As the piston moves towards bottom dead center, the volume of burnt gases increases from 4 to 5. At point 5, the transfer port opens, TPO, and the suction stroke starts. Thus, the actual PV diagrams for 4-stroke and 2-stroke SI and CA engine was drawn, and it is studied.